Before we start doing the problems, I would like to go over some basics about leap years. So a leap year is a year where there are 366 days instead of the usual 365 days. So this always occurs on February 29th. So how do we figure out if it is a leap year or not? So leap years are any year that can be exactly divided by 4, such as 2016, 2020, and 2024. It is not a leap year if it is divisible by 100, such as 2100 or 2200. But it is a leap year if it is divisible by 400, such as the year 2000 and 2400. You might be wondering why we have leap years. This is because it takes Earth 365.242375 days to orbit around the Sun. If each year was 365 days, then we would be losing 0.242375 days a year. To account for the 0.242375 days a year, we have leap years. So the first rule above makes our total number of days in a year 365.25. The second rule makes the total number of days in a year 365.24. Our final rule makes it 365.2425 days in a year, which is very close to 365.242375 days in a year. So this is why we have the 3 rules to determine a leap year. For this problem, we have to figure out how old Marissa is this year. So this is her birthday cake from last year, and we can count the number of candles on this cake. So we get that there are 8 candles. So that means Marissa was 8 years old last year. So since she is 1 year older this year, we can add 1 to 8. So we can do 8 plus 1 is equal to 9. So that means Marissa is 9 years old this year. For this problem, we have to figure out what day of the week Tom's birthday was. So we are given that Tom turned 5 years old 4 days ago. So that means his birthday was 4 days ago. So to find what day of the week that was, we can just simply go back 4 days. So going back 4 days, we would get Wednesday. So Wednesday would be the answer to this problem. For this problem, we have to find the age of each puppy using the clues below. So our first clue is that the youngest puppy wears a pink bandana. So looking at the puppies we have here, we see that Rusty is wearing a pink bandana. So that means Rusty is our youngest puppy. So Rusty is 2 months old. Looking at our second clue, we see that the oldest puppy wears a green bandana. Bonnie is wearing a green bandana, so that means Bonnie is our oldest puppy. So Bonnie is 7 months old. Finally, looking at our last clue, we see that Romeo is our second youngest puppy. So that means Romeo is 3 months old. So that leaves us with one more puppy called Kiki. And looking at the ages we have, we see that only 5 months old is left. So that means Kiki is 5 months old. For this problem, we have to figure out how old Miranda's cat is. We are given that Miranda is 7 years old. And we also know that her brother is 2 years younger than her. So we can find our brother's age by doing 7 minus 2, and we get 5. And finally, we know that Miranda's age plus her brother's age plus their cat's age is 15. So to find how old her cat is, we can simply do 15 minus 7 minus 5, and we get that her cat is 3 years old. For this problem, we have to figure out how many different ways Myra can put red and blue candles on her cake. So we can make a chart to stay organized. So we can have the number of red candles on the left side and the number of blue candles on the right side. So Myra could have 0 red and 5 blue. She could also have 1 red, 4 blue, 2 red, 3 blue, 3 red, 2 blue, 4 red, 1 blue, and finally 5 red and 0 blue. So we can count the number of ways and we get that there are 6 ways. So the answer to this problem would be 6 different ways. For this problem, we need to find out how many candy bars and balloons Alexander will need. So we know that Alexander is going to invite 5 friends to the party, and each friend will get 3 candy bars and 2 balloons. So to find the number of candy bars he needs, we can simply do 5 times 3, and we get 15, so he needs 15 candy bars. To find the number of balloons he needs, we can do 5 times 2, and we get 10, so he needs 10 balloons. So our answer to this problem would be 15 candy bars and 10 balloons. For this problem, we need to find how many balloons and strings they will need. So Samuel invited 9 children to his birthday party. 9 children plus Samuel is 10 children in total. And each pair is 2 people. So we can do 10 divided by 2 to get 5 pairs. And each pair will need 1 balloon. So we can do 5 times 1 to get 5 balloons. And each pair also needs 4 strings. So we can do 5 times 4 and we get 20 strings. So the answer to this problem would be 5 balloons and 20 strings. For this problem, we have to figure out who is sitting on either side of Tanisha. So we know that Quentin sits in the chair between Peter and Sujita. So we could put Quentin between Peter and Sujita. So we also know that Tanisha is not next to Sujita. So Tanisha has to be in this spot. So that leaves us with Ron. So Ron is here. So now we can look at our table and we can see who is sitting on either side of Tanisha. So that would be Peter and Ron. So Peter and Ron is our answer. For this problem, we have to figure out what coins Kyra received for her birthday. So we know that Kyra received 7 coins that are worth 48 cents, and she has at least 1 coin of each type. So that means she has at least 1 quarter, 1 dime, 1 nickel, and 1 penny. So we can add up the value of these 4 coins. So a quarter is 25 cents plus 10 cents plus 5 cents plus 1 cent, and that would give us 41 cents. So 41 is 7 less than 48, so we're only 7 cents away from 48 cents. So now let's see how many coins away from 7 coins we are. So we can do 7 minus the 4 coins we have, and we would get 3. So we need 3 more coins that are worth 7 cents. And the only way that 3 coins can be worth 7 cents is if we have 1 nickel and 2 pennies. So now we can add our 1 nickel and 2 pennies to the coins we already have. So our final answer to this problem would be 1 quarter, 1 dime, 2 nickels, and 3 pennies. For this problem, we have to figure out what day Cynthia's birthday is. So we know that her birthday is on the 31st day of the month, and that her cousins, who are 5 years younger than her, will celebrate their birthdays on the day of Halloween. So the day of Halloween is October 31st. And since they are 5 months younger, that means Cynthia celebrated her birthdays 5 months before the cousins. So we can just count back 5 months. So this would be 1 month, 2 months, 3 months, 4 months, and 5 months. So her birthday occurs in May. And since it's on the 31st day of the month, we know her birthday is on May 31st. For this problem, we have to figure out how old Joshie is. So we know that Annie is turning 8 years old this year. Joshie is 3 times as old as Daniel, and their total age adds up to 60 years. We can use this square to represent Daniel's age. Since we know that Joshie is 3 times older than Daniel, we can use 3 squares to represent Joshie's age. Joshie and Daniel's age adds up to 52, so that means the sum of these 4 squares is also 52. So we can just divide 52 by 4 to find what each square is equal to. So this means each square is equal to 13. So we can just multiply 3 times 13 to get Joshie's age, since Joshie's age is equal to 3 of these squares. So solving this, we get 39. So the answer to this problem is 39 years old. For this problem, we have to find out the number of candies in this jar to begin with. We know that Emma and her friends ate half the candies on her birthday, so that means half the candy is left. The next day, they ate 3/4 of the number of candies they had eaten the day before, so we can subtract 3/4 times 1/2, since they ate 1/2 of the candy yesterday. We can solve this and we get 1/8. So that means there's only 1/8 the original amount of candies in this jar. Let's have each square represent 1/8 of the jar. Since we had a full jar to begin with, that means we need 8 of these squares in order to represent the entire jar. We just found out 1/8 of the jar represents 8 candies, so each of these squares represents 8 candies. We can find the amount of candy they begin with by adding up these 8 squares. So adding up these 8 squares is also equal to 8 times 8. So we can just solve 8 times 8 and we get 64. So we began with 64 candies. For this problem, we have to find out what day of the week February 24th, 2014 was. We know that March 28th, 2014 was a Friday. First, we can find the number of days between these two dates. We know that there are 28 days in March, and since 2014 is not a leap year, there are 28 days in February. So we can do 28 minus 24 to get 4 days. Now we can add 28 plus 4 to get 32. So the anniversary occurred 32 days ago. Since there are 7 days in the week, we can do 32 divided by 7 and we get 4 with a remainder of 4. We only care about the remainder since we're finding the day of the week. So that means their anniversary occurred 4 days ago from Friday. So we can just count back 4 days. This would be 1 day, 2 days, 3 days, 4 days. So that means their anniversary occurred on Monday. For this problem, we have to figure out if the policies are fair or not. Ella's policy is that she receives $10 on her 10th birthday, and each birthday after she gets a $2 raise. So she gets $12 on her 11th birthday and $14 on her 12th birthday. So the amount of money she gets each year would look something like this. We can figure out how much money she received through her 21 birthdays by making pairs that add up to the same number. For example, 10 and 50 add up to 60, 12 and 48 add up to 60, 14 and 46 add up to 60, and so on. So each pair adds up to 60. And we can now find the number of pairs we have. We have 21 birthdays, and each pair is consisted of 2 numbers, so we divide 21 by 2, and we get 10.5 pairs. Now we do 60 times 10.5, and we get 630. So Ella receives $630 in total. To find how much money Lucy receives every year, you can make a chart. If you make a chart, you see by her 26th birthday, Lucy receives $655.36, which is already greater than the total amount of money Ella receives through her 21 birthdays. Thus, the policy is unfair as Lucy receives more money than Ella. For this problem, we have to figure out what day of the week it will be when Tony turns 13 years old. We know that Tony celebrated his 10th birthday on October 1st, 2019. So that means he will be celebrating his 13th birthday on October 1st, 2022. To determine what day Tony will be turning 13 years old, we need to find the number of days between his 10th and 13th birthday. 2020 is a leap year, so there are 366 days in 2020. 2021 and 2022 are not leap years, so there are 365 days in each year. We can add all of these up and we get 1096. Now we have to divide 1096 by 7 since there are 7 days in a week, and we get 156 with a remainder of 4. So this means Tony's birthday will be 4 days after Tuesday. So we could just count 4 days. So this would be 1 day, 2 days, 3 days, and 4 days. So Tony's birthday is on a Saturday. For this problem, we have to figure out how old Andy and Nate are. We know that Andy has a birthday on the same day as Nate. We also know that Andy is 3 times older than Nate. Finally, in 10 years, Andy will be 12 years older than Nate. We can use one block to represent Nate's age. Andy's age can be represented by using 3 blocks since Andy is 3 times older than Nate. We also know that Andy is 12 years older than Nate, so the difference between Andy's age and Nate's age is 12 years, which happens to be 2 blocks. So these 2 blocks represent 12 years. To find what each block represents, we can simply do 12 divided by 2, and we get 6. So each of these blocks represents 6. So this means Nate's age is 6 and Andy's age is 3 times 6, which is 18. For this problem, we have to figure out how old Ryan was 5 years ago. We know that Ryan is 4 years older than Eric, and 5 years ago, Ryan was twice as old as Eric. So Eric's age 5 years ago can be represented with this block. Ryan's age 5 years ago can be represented with 2 blocks since Ryan is twice as old as Eric. This problem also tells us that Ryan was 4 years older than Eric. So the difference between Ryan's age and Eric's age is 4. So that means each block represents 4. So to find Ryan's age 5 years ago, we can simply do 2 times 4. And we get 8. So Ryan's age 5 years ago is 8. For this problem, we have to figure out what date Lynn was born. We know that Lynn saved a nickel every day starting at the age of 4. If today is October 1st, 2020, Lynn has $47.55. Based on this information, we can figure out when Lynn started saving money. She has accumulated $47.55, so we can divide that by the amount she saved each day. In this case, she saved 5 cents every day. So doing 47.55 divided by 0.05, we get 951. Next, we subtract whole years to get this number closer to 0. Since 2020 is a leap year, we subtract 366. 2019 is not a leap year, so we subtract 365. And finally, 2018 is also not a leap year, so we subtract 365. And this gives us a total of 145. We went 3 years back, so right now it is October 1st, 2017. Now we can start subtracting from 145. There are 30 more days in October since 31 minus 1 is equal to 30. There are 30 more days in November, 31 days in December, and 31 days in January. So solving this, we get 23. That means her birthday was 23 days into February. So her birthday is on February 23rd. The problem says she was born in 2014. So the answer to this problem is February 23rd, 2014.